Welcome to this video from the RC Ground School. In this video, we're going to talk about the final steps in getting your model ready to fly. That includes setting up your transmitter and making final adjustments. Let's start with the transmitter. I'm going to assume that you have a computer radio that has a variety of variables you can set through menus on the radio's computer screen. The first step is to review your radio's instructions to get both an idea of how to maneuver within the menus and get a basic understanding of the variables you can control. Here are some of the main variables you'll want to set for your model. First, you'll want to select the type of model it is and give it a name. Select the choice that corresponds with an airplane versus a helicopter or drone. Most transmitters will also have you select the type of wing the model has. This usually includes specifying the number of aileron servos and if the wing includes flaps. You'll also want to set up dual rates. Your model's instructions may specify dual rate settings. Dual rate switches will allow you to select how much the flight controls move at full stick deflection. You may want to start with low rates until you get the feel for the model. I prefer to set my dual rate settings for all my flight controls on the same switch. I can set low and high rates on a 2-position switch or low, medium, and high rates on a 3-position switch. If your model's instructions don't specify dual rate settings, consider using 70% for low rates and 100% for high rates. Next, refer to the model's instructions and see if it recommends control stick expo or exponential stick movement. You'll normally set expo as a percent of total movement. For most brands, positive expo results in reduced control movement for stick movements near the center of the range. A little expo can smooth out the nervous inputs new pilots often experience. Expo doesn't limit total control throw, only the rate at which the controls get to its limit. Another function you'll want to understand and perhaps set up is called mixes. A mix allows you to mix two channels together to the degree that you decide. For example, many new pilots mix in 20 to 25% rudder with their aileron channel. When they roll the airplane, the rudder will automatically offset to help prevent adverse yaw during the turn. You might also find it necessary to mix in either up or down elevator when lowering the flaps. You'll find that mix either in the Mix menu or in the Flap menu. There will also be some general settings you'll need to define. These will include things like timer settings, screen brightness, and other things that don't require the airplane to be connected. When you've worked through these items, it's time to review the receiver binding procedures for the transmitter brand you're using. Some may include a bind plug that connects to a special slot in the receiver, or it may involve pushing a bind mode button on the receiver. Make sure you understand the steps, as the transmitter and receiver won't bind unless the steps are followed exactly. With the prop off the airplane, complete the bind procedures to ensure the transmitter and receiver are talking to each other. At that point, there are a couple of more transmitter setup variables you'll need to set. Again, depending on brand, you may need to set up the onboard stabilizer using the stabilizer menu on the transmitter. Detrim transmitters and receivers use this method. In other cases, you may need to make manual adjustments on the stabilizer adjustment knobs on the stabilizer or receiver. At this point, there are a couple of other adjustments you'll need to make or at least verify. First, do the controls move in the proper direction? If not, you'll need to go to the servo menu and reverse the affected servo. You'll also need to check that the flaps move the proper direction and the proper amount. Make adjustments in the flap system menu to get the movements you desire. With the model powered on, you may need to make adjustments to the control surfaces. It's best to get the surfaces aligned with their respective aircraft structure using mechanical means. That might mean detaching and screwing the clevis in or out, or perhaps loosening the set screw on a mini connector and sliding the control rod in or out. Depending on the model, these mini connectors can be at either the servo end or the control surface end of the control rod. When you have them aligned as close as you can use the sub-trim menu to make fine adjustments. Again, remember, if you've got the model powered on, the propeller should be taken off. With trainer airplanes, you'll almost always get close enough with mechanical adjustments. The last thing you need to check is the model's center of gravity. To do that, you'll want to unplug the battery but leave it in the model and install the propeller. The model's instructions should show you where the aircraft's center of gravity should be. It's the point where the model should balance fore and aft. Side-to-side balance is not normally a problem with trainer aircraft. CG is normally listed millimeters aft of the leading edge of the wing at the fuselage. Measure the distance and make either a mark or clip off most of the shaft from a straight pin and press it into the wing at the correct spot. Pins with small round heads work well. They'll be easy to feel. With high wing planes, slide your fingertips beneath the wing and lift the plane where the pins or marks are. If the plane tips nose low, slide the battery back. If it tips tail low, slide the battery forward. Most trainers can be balanced by moving the battery. When you get the balance right, mark the battery position in the battery bay to make placing the battery easy next flight. If the plane won't balance with the battery at one extreme or the other, either try a larger, heavier battery or add some lead weight. The plane's CG is important to a successful flight. There's an old saying that says, a nose-heavy airplane won't fly well, but a tail-heavy airplane won't fly long. It's rare to have to add weight to a trainer model unless you've made changes such as adding a bigger motor or changed servo placement. The last thing to check before your first flight is the connection between the transmitter and the receiver. This is called a range check. Follow the instructions that came with your transmitter. Basically, have someone hold your model while powering it on. You'll then put your transmitter into range check mode and move 30 to 40 yards away while checking your model's control movements. Your helper can indicate movements if you can't see them. If everything works as expected during this reduced power status, you can have confidence that the transmitter and receiver will provide a solid signal up to the specified range in your transmitter's specifications. As we close this video out, if you found it helpful, please click on the thumbs up icon and subscribe to the RCPlaneviews.com channel. Click the bell icon to be notified when I post new videos. Thanks for watching.